are live. Okay, so today we do 5.6, which is the substitution rule. I call it U sub. You need to do the substitution. If you don't do this, you won't get it right. I'm serious. So last night in my review session for my differential equations class, for the most part, I don't use U sub, but occasionally I do. The professor was doing U sub.
No way.
Yeah, wait. Well, but he's teaching people at all different levels. Because people are in graduate school, they don't all teach calculus. Last semester there were 2 middle school teachers in my class. They were young, so they probably remember more than I do, but still. So he does U sub to help them out. So no, it really is a real tool. A college professor teaching a graduate level math class is still using it to show people things. Well, and this is what my class is all about, is solve the differential equation. For you, every time you see solve the, I know what I think every time I see it. What do you think when you see solve the differential equation? Huh? Okay, what is a differential equation? It's a derivative equation. Derivative. So this means derivative. We've already gone over this before, but I think y'all have forgotten. This is a derivative equation. It's the derivative. How do we undo the derivative? So that means you have to integrate. So when they say solve the differential equation, they mean integrate until you get to what? Y equals. Right now it's really simple for y'all. You'll have to maybe do once or twice. If I give you the second derivative, you integrate it twice to get to y. And in my class, it's much more complicated than that. Much more complicated than that. But that's pretty much what it means. It means keep integrating until you get to y equals. Why am I saying this? Because now that you know how to integrate, sometimes they'll just give you an integral and say solve, and you do whatever it is, right? Other times they will say solve the differential equation. And y'all sit there and go, huh? All right, it means you know how to integrate, so now you're going to integrate. Okay, so we have a derivative. And I'm just gonna, for U sub, the best way to do this is just to do examples. And then I will give you my suggestions on how to do this, which is my hints, which you should follow. I'm going to give you a derivative equation, which means it's a differential equation. And they're going to say solve. Sometimes they don't even say solve the differential equation. Sometimes they just say, so this is example 1. Example 1. Solve, I can't spell. Solve dy dx equals, that's messy, cosine of 3x. Is that a derivative? To solve it, I want y equals. How do you undo a derivative? Integrate, right? You want an antiderivative. So the way this is explained, and we will get into this more later on in another chapter, but for purposes of, just because I don't want to teach you wrong yet, and this is exactly what my graduate professor said. You do what's called separating the variables. You know how we did implicit, where we had x's and y's mixed up and had to take the derivative? We do that on integration too. And what we do is we put all the y's on one side of the equation and all the things with x on the other. Is that a thing with x in it? You're going to swing it up over here. Now, think about when it was delta y over delta x. Can we multiply by delta x both sides, right? Suppose it was this. Can I multiply both sides by delta x and get rid of the delta x? Right? And then did we just do an infinite number of those and that became dy and dx? It's like this, but you're not really multiplying. It's what's called separating variables. It's a subtle point, but all I'm saying is don't ever say that you're multiplying by dx. Say you're separating variables. This is separating variables. And what you end up with, if you do this right, you always end up with the dy on the left and the dx on the right. Every single time. So you're going to put all the y's on the right, all the x's on the left. Right now, for the easy ones we're doing, there's not going to be a y, there's just going to be a dy. So what's it look like? It looks like dy equals cosine of 3x dx. And you've actually already learned to do this one because I showed you the just thing to memorize, right? So if we want to undo a derivative, do we integrate? Oops, it slid on me. Now what is there in front of that dy? Is there always a 1 there? Okay, whose derivative is 1? X. Or in this case, it has to match this variable, so what is it? Y. So now that means that's y equal to, you already learned that this was going to be 1/3 cosine of 3x, right? I mean 1/3 sine of 3x. Here's how we do this now. This is a composite function. Is there an inner function and an outer function? Yes. So there's an inner function and an outer function. That's my inner function. We're going to call that u. Because remember how I said there's a u sub? Okay, we're going to substitute in, we're going to take the 3x and we're going to put u in. 3x is tired, we're going to put u in. U's got fresh legs. We're playing soccer because it's soccer season. All right, so u is equal to 3x, because y'all don't do substitutions in golf. I can't talk about that one. Right? We can do it in football, but it's not football season anymore. It's soccer season. And my water polo team is not until 4th period, so I can't talk about water polo. But it's soccer. Yes? All right. What this becomes then we need to figure out what du is. So we're going to take the derivative, and it's kind of implicitly. The derivative of u is du. The derivative of 3x is 3dx. Do y'all see what I did? Now, I have a dx up here, so that means I want to solve for this dx. If I get dx by itself, what do I have to do with the 3? Do I have to divide by it? Does this become 1/3 du? I divide by 3, that means I have a 1/3 out front. Does my dx equal 1/3 du? If I do the substitutions in here, I'm going to pull the 1, well actually no I'm not, I'm going to write it all out for y'all first. So I have the integral of cosine, and I'm going to put my u in here, and I'm going to put my 1/3, if I could write, third du here. Can I pull the 1/3 all the way out in front? I can factor it out. So y equals 1/3 integral of cosine of u du. And what is the integral of cosine? Whose derivative is cosine? Hello? Anybody awake? Sine, right? So is this just going to be sine of u, 1/3 out in front, plus c? Well, what was my u? 3x. So we put it back, and we get 1/3 sine of 3x plus c. And was that what you were taught before when it was cosine of ax? Its antiderivative is 1 over a sine of ax plus c. Is this why? This is why that rule worked. The advantage of u sub is if you will do this, the problem is y'all don't see patterns when it's composites. When I see a function within a function, first I can see a function within a function, and then I was taught just to recognize the pattern and know that I needed a coefficient out front to fix it. Because it's chain rule. If it's a composite function, is it chain rule? Is this derivative going to be chain rule? When I take the derivative of this, am I going to produce a 3 cosine of 3x? I don't have the 3 here. I was taught that I needed that 3 there, so I have to put a 1/3 out front. That's the way I was taught. Y'all are taught u sub. It's much, with the easy ones, it doesn't matter. When we get to the hard ones, u sub will help. I cannot tell you how much easier it is with u sub than what I learned. There are times, most of the time, like these easy ones, I don't use U-sub. Like in my homework and my differential equations. But when I get to something complicated, I use U-sub because it really is easy to see the pattern. I promise you, it's worth doing. All right, let's try one that's worth doing. This is example 2. And they say solve, and they give you dy dx equal to 10x squared over the square root of 1 plus x cubed. Oh, how do I solve that differential equation? Once again, am I going to integrate it to get y? If I want to get y, do I need to separate the variables and get all the x's on the right and keep all the y's on the left? There are no other y's other than dy. Am I only going to have dy on the left for now? So when I separate, I'm going to have the integral of dy equals the integral of 10x squared over 1 plus x cubed, square root. Ruh-roh, that's complicated. Do you see it's complicated? Not really. I want you to look right here. What is if I say that my u is equal to 1 plus x cubed, what is du going to be? What's the derivative of 1? 0. What's the derivative of x cubed? 3x squared dx. Oh, I forgot my dx. Woo! I need a dx right there. Uh-oh. Do you see that there's an x squared dx right here? And I have an x squared dx right here. Can I solve for that and do a substitution? Can I call this u? And then what do I need? Is this, oh, did I do the 1/3 again? Oh my goodness. I'm so tricky. So is this going to become 1/3 du? How did I know that? Because I looked for the one that's the highest order. And I know that if it's x cubed, its derivative is going to have x squared in it, right? There's an x squared up there. Am I only fixing the coefficient? That's all you're doing with u-sub. But sometimes it's hard to see, especially when you're beginning. Okay, so what do we become? What's the integral of dy? Just y. Yeah, y equals, hang on, I don't like that. Let me go, it's y equals the integral, and I'm going to pull the 10 out in front, and I'm going to pull the 1/3 out in front. Yes? I'm pulling that 1/3 and that 10 out in front. Then do I have 1 over u du? Oh, sorry, square root. Well, can I rewrite that as a fractional power, and can I change the sign and get it up in the numerator? Does everyone see that that becomes u to the negative 1/2 power? 10/3 integral of u to the negative 1/2 du. How do I do an antiderivative of a power? No, that's derivatives. Add 1 and then divide by the new power. So what's 1 plus a negative 1/2? So it's u to the 1/2, and what is my new power that I'm dividing by? 1/2. Dividing by half is the same as multiplying by what? 2. So am I going to flip that up? This is plus c, and I'm running out of room, but is this going to equal to 20/3 square root of my original? So I'm going to write down here, equals 20/3. Actually, it's not going to print. Hang on. I'm going to go to another page because this is just not working for me. First, I need to move this one all the way up. I'll do that later. So what did I get to? I got to y equals 20/3, right? U to the 1/2 is square root of what was my original? 1 plus x cubed plus c. Well, that wasn't too bad. Now that you see how to do it, is that not too bad? Is it going to take practice? Yes. So, to recap, your book will say, this is your book. Your book will say, it says, change of variables. That's what they call this. This is what my college professor also calls it. And then he'll go and say u sub anyway. Change of variable, that means u sub. What variable did I change? I changed from x's to u's. And why did I do that? So that I could simplify it so you could see the overall pattern. What you are doing is you have a composite function. You have an outer function and an inner function. And this helps you to simplify the inner function so you can see the outer function and realize it's just chain rule. And you're undoing chain rule. Really, really. Okay, so let's do, this is number 28. Oops. Page 408 in the book, just so you know where it comes from. And they want you to solve, they're not going to solve this time. They're just going to say, solve, but they're going to give you an integral. Okay, so another hint on finding u sub is find the things that are most complicated. This is fairly simple, but it's a little messy, right? It's a little messy. This is a weird one. We're going to pick the worst thing we can find. That's going to be our u. Now, there's two ways to work this problem. This is one way to work it. I'll show you another way later, like in chapter 7. But for right now, we're going to use this one. We're going to say that's u. U equals x minus 2. What's du equal? Just dx, right? All right, well, that would end up giving me the integral of x over u du. I still have an x, but guess what I'm going to do? I'm going to solve this. I'm going to solve that one for x and get this in terms of u. Actually, I circled the wrong thing. I meant to circle this one. I'm going to solve for this one. So does that tell me that x is equal to u plus 2? So when I change this, does this now become u plus 2 over u du? Your other choice on this one is to do long division. And for something this simple, I don't want to do long division. I want to do something easier. Can I break that into two fractions? Have I been doing this to you since the week 1? 2 things on top, 1 on bottom. Can you break that into 2 fractions? And you still have to do it. We did this on the last test. Or I was expecting you to do it in the last test. I think it was the last test. I don't remember anymore. So what does this equal? It equals the integral of 1. Right? And I'm going to just do a dx. Oh, sorry, du. du. Plus 2 integral of 1 over u du. Do those look familiar? What's the integral of 1 in terms of u? Just a u, right? It's just u. Yes. Plus 2. What's 1 over u du? Or what's 1 over x dx? Huh? Yes. Natural log, absolute value, because we don't know, of u plus c. Well, what was my u? X minus 2 plus 2 natural log, absolute value of x minus 2 plus c.
Einfach easy.
That's German. Yeah. Eins, fine. Yeah. Last example. No, I'm not going to do that one. Now we're going to talk about, so that's the tricky ones. Now, want hints on how to pick u? For starters, just as an overall rule, look in the denominator. Look, it's the innermost function. Because remember with chain rule, you had to take the wrapper off to get to the inner part, right? Well, now we're making the inner part simple. We're taking a Tootsie Pop and turning it into a peppermint. We just want to look at the wrapper right now. So no matter how complicated the inside is, we're going to call that u, and then the wrapper is the outside function. And then we see the overall pattern. We can integrate it and then do a substitution back, and we're back in our x's. So Let me get a whole new page. See, these are hints. Hints for choosing u. Because I choose you. Aw, it's close to Valentine's Day. Okay, 1. You are going to look. That's you looking. You're going to look for stuff. The stuff is the peppermint or the Tootsie Pop candy. It's the candy. It's the sweet stuff. It's the inner function. This is how you're choosing you. You're going to look for stuff that's raised to a power. Oops. Suppose it's stuff to the 99th power. U is equal to stuff. Does that make it a lot easier? Because if you're integrating u to the 99th power, what are you going to do? Add 1 and divide by 100, right? Simple, right? Yes. And then you got to find du equal, right? And is that going to end up being a coefficient change? That's all you're doing, is you're trying to figure out what it is so you can take its derivative and find the right coefficient. Next, the first thing you're always looking for is something raised to a power. Actually, you're always looking for stuff in the denominator. I should write that right now. Look for stuff in the denominator. That's really a big, if the most complicated thing there is in the denominator, that's the u. So if you have 1 over stuff, it's going to go to 1 over u, and you're probably going to integrate and get natural log of something, aren't you? But what if it's stuff raised to a power in the denominator? Then it's just a negative power, right? So if I have 1 over stuff to the 10th power, that becomes 1 over u to the 10th, and that is going to equal to u to the negative 10. Is that just a power rule? Go back to part 1. You see that now? You see how I can play these games? Oh, well, guess what? There's another one. Then there's look for stuff under a radical. Is that still just a power? But I make a big deal about it because it's harder. It's a fractional power, and it's easy to spot. If I have square root of stuff, or I have cube root of stuff, is this u to the 1/2 power or u to the 1/3 power? Is that what you're going to do? What if I put that in the denominator? What if I do 1 over cube root of stuff? Yeah, is that the same as saying u to the negative 1/3 power? Do you see where I'm going with this? So for me, if it's in the denominator and it's a radical, that's like a neon sign saying, pick me, pick me, pick me. And the last thing is if you have, where am I at, 4? 4, it's look for stuff inside a trig function. Is that the angle? So the angle is equal to stuff, right? So if I have tangent of stuff, that means I'm going to transform it to tangent of u, and then I'm going to take its derivative and I'm going to have just a coefficient change. Every single time. So to recap, look in the denominator, look at the denominator, look at the denominator, look under radical signs, look at something raised to a power, look at something inside of something else, right? And then you want to use the integral stuff you know already, which you know power rule, and you should be good at it, right? If you can ever do power rule, do power rule. Do you know natural log yet? If you don't, you will by the time we're finished. If it's 1 over something, and it's not raised to a power, then it's natural log. If it's raised to a power, it's a negative power, right? Is that the subtle difference? Y'all are going to have to practice.